Good morning, everyone. Mr. B is back today. We're going to be moving on from earthquakes and moving on to the final lesson in our Earth's crust unit, which is called the theory of continental drift. And we're going to focus on this for 3 mini lessons before we wrap up. Now, just going back now to do a little review. The picture right here is the island of Santorini in Greece, where the famed city of Atlantis was destroyed by a volcano. And there's the volcano on GPS, still growing today. Up in the top corner here, we have an example of a shield volcano with some lava erupting out of it. Down here, we have a train track which was built directly on a fault line, which is why you see the track being bent in that way. Over here, we have a seismogram, a printout from a seismograph or a seismometer showing P waves, S waves, and then L waves. Over here, we have the layers of the Earth. We have the crust, the thin outermost layer, the mantle, the largest layer, kind of like a taffy, the completely liquid outer core, and the solid spinning metal inner core. Today, we're going to get into the last picture, which is right over here, by going into talking about what do earthquakes cause this planet to do, or what is it an example of? And we're going to start by talking about a German scientist today by the name of Alfred Wegener. Now, Wegener doesn't get a lot of attention. We all sort of know big names like Albert Einstein or Isaac Newton. We often don't hear too much about this gentleman named Alfred Wegener, who was a German scientist who proposed in 1915. Now, first of all, you have to understand the dates here. Canada was fully engaged in World War I, starting in 1914. So when Alfred Wegener was proposing his theories, Canada was at war with Germany. So it wasn't like these ideas were getting shared at the moment, at least. So he proposed during World War I that the continents were slowly drifting apart, a theory that he would call continental drift, as in the continents are drifting. Now, the interesting thing here is this is a pretty bold theory. I mean, how do you prove that? How do you prove that the continents are actually moving apart? And when did they start? Where are they going? There's a lot of questions here. And Wegener wasn't going to be just, his theory wasn't just accepted. He did have some evidence, and we're going to go through his evidence today. So Wegener proposed or said that all of the continents were once joined together in a supercontinent. Now, he actually gave this supercontinent a name, and he called it Pangaea or Pangea. It doesn't really matter how you say it. And if you look here, you can see here's North America, South America, which are, we know where they are today. But Europe is sort of all mishmashed in here. Africa is crunched in here. Antarctica, crunched in here. India is actually over here. And then the rest of Asia is over here with a large C here. And he said this happened about 200 million years ago is when they started breaking apart and moving away from each other. So again, Wegener believed that about 200 million years ago, the entire continent, all the continents we know today, were once bunched together in what he calls a supercontinent. Now, the continents broke apart around 200 million years ago, and they slowly, over that time, drifted to where they are today. Now, here's a video of what that would look like. So you see Africa is now apart. It's joining up with Asia. South America sort of floats downwards. Antarctica settles where it is. And that's sort of how Wegener believed that the world was how the continents were moving. Now, he has 4 pieces of evidence. And I want you to listen to these because you're going to be deciding at the end whether you agree with his evidence. The first one is what he just simply called puzzle pieces, or the fit of the continents. And he just said if you look at them, just by staring at a map and examining the coastlines, they look like they fit together. Specifically South America and Africa, where South America has a big bulge here where Brazil is, Africa has an indent here. And it looks like they would have at one time fit together. So he believed that the coastlines of Africa and South America look like they fit together. Now the problem here, of course, is it's hard to fit the rest of them in. It's easy with those ones, but a little harder when we're thinking about the rest of them. Wegener then noticed that the other continents looked like they could have fit together too. Now, some people say, of course, the people who challenged Wagner simply said, well, I mean, you can make anything look like it fits together if you put it the right way. So that it's not a great piece of evidence, but it is hard to deny that Africa and South America do look like they fit together. The rest of them, it's a little more iffy. This is probably one of his more compelling pieces of evidence, and this is what he referred to as fossil evidence. I'm sorry, my camera seems to be out of focus here. Let me give me a second. I'm going to try to get it in focus. I apologize, guys. I don't want you to... Sometimes I'm just talking away here, and I can't... I'm also in a different room today. I'm usually in my classroom, but they're cleaning my classroom this week, so we'll try that. Fossil evidence. This was his second piece of evidence. And Wagner noted, and he was right too, by the way, that fossils of the same plants and animals are found today on widely separated continents, including Africa, South America, Antarctica, Australia, and Asia/India. And we're going to look at a few of those examples. But of course, by the 20th century, in the 1900s, people were already excavating fossils from all over the world, both remains of plants and animals. And some people say, well, what remains do plants have? Well, roots and seeds, and it's all types of things that we can retrieve from plants. And of course, for animals or other types of organisms, we have bones. And what they started to find as they started to piece these together was that many of these creatures were on very different continents. So the first one was known as a Mesosaurus. And if you actually go to the Manitoba Museum, they have one there because we found them in Canada. Sorry, I lied. That's Mosasaurus. Sorry, very similar name. The Mesosaurus fossils have only been found in South America and Africa. So this creature here, the fossils that make up this entire creature, the Mesosaurus, are only found in Africa and South America. But Africa and South America, as we know them, are separated by the Atlantic Ocean. So how in the world was this creature there? Well, some could argue that it swam. It does look like it has, webbed feet and webbed hands and a tail. It is, possible that it swam. But then you have to think about this for a second. The Mesosaurus was a freshwater reptile, which meant it could not migrate across the ocean, which is a saltwater body. The Lystrosaurus. Now, fossils of this little land reptile were found in Africa, India, and Antarctica. Yes, Antarctica, if you can believe that or not. So that's quite amazing that this little small dinosaur was on all three of those continents. Now, how does that happen? This is not a marine-based creature. It doesn't swim. It would have been even harder to imagine this creature swimming across an ocean. Now, here's the Signathus. I always pronounce this one wrong. Now, fossils of this creature are found in Africa and South America. Again, this doesn't make sense unless you assume that at some point the continents were together. Now, here's an interesting tree, the Glossopetrus. Now, this is an interesting tree because we found evidence of this tree, and what I mean by that is fossilized wood. We also have seeds and other things that have been found of this tree are found in South America, Africa, India, and Australia. Now, that is one mobile tree. I'm telling you, this thing gets around. Now, of course, none of these living things had to move anywhere if Wagner were right. If Wagner were right, all of these creatures would have been together. And then as the continents drifted, of course, that's why we found their fossils in different areas. So if you watch here, we're going to show, there's Pangaea 200 million years ago. Here's the locations of Glossopetrus and Lysistrosaurus. They would have all been in the same area. But as the continents drifted apart slowly over time, we ended up finding their remains on different continents, separated by vast oceans. Now, his third piece of evidence is mountain chains. And what Wagner looked at was two specific mountain chains. The first one called the Appalachian Mountains on the or the east coast of North America, which runs all the way from New Brunswick and Nova Scotia all the way down to the Carolinas. And then he looked at another set of mountains in Europe called the Ural Mountains. Now, here's the interesting thing. He speculated that, of course, if the continents were together, these mountain chains would have never separated at all. There's the Appalachians, and of course, now we're into the other ones. Sorry, I'm going to go back. And if the continents were together, this chain would have just been one big chain, instead of separated here and then separated here. Kind of interesting. Again, this is just his evidence. It doesn't mean that it's right. At the time, a lot of people didn't really believe him. And his final piece of evidence is what we know as climate evidence. Now, as we approach the 20th century, there was more and more evidence piling on that glaciers existed around the equator at some point. Now, that's really weird because the equator is one of the hottest places on the planet. How in the world would glaciers or glacial remains be found all the way at the equator? The other weird thing is that tropical plant remains have been found in the Arctic and Antarctic. That seems strange too. Those are climates that would not allow tropical plants to grow there. So there are remains of glaciers near the equator and tropical plants around the Arctic. Now, again, if you put all the continents back to Pangaea, as Wegener proposed, that makes sense. That totally makes sense. You're going to have glaciers all piled up in areas where they should be, and tropical plants where they should be too. And of course, they drifted. Now, in spite of all of this evidence, the scientific community rejected Wegener's ideas, and he was forgotten about for almost 50 years. So Wegener had a cool idea, but nobody believed him. The reason they didn't believe him is he had no evidence to show how they moved. It was one thing to say that they might have moved, but he couldn't tell you how they moved. And that was a big, big no-no for the scientific community, who was not, at the time, willing to accept Wegener's theories. Now, once this sheet, the note-taking guide, is filled out, we're ready to move on. And I wanted you to think about just the idea of, do you think that Wegener's evidence was good? And if so, which piece of evidence do you think was? And if you don't agree with his theory, why do you think he was wrong? What evidence was the least compelling for you? Thanks for watching again today, guys. We're going to meet again for our next video called Continental Drift Reborn, which will be in a few days from now. And then we'll move on to the final lesson plan called The Theory of Tectonic Plates. Talk to you soon. Bye now.